Next, let's proceed to the next chapter, which is Chapter 8, Hypothesis Testing. Let's talk about what is hypothesis testing. Hypothesis testing is a form of statistical inference that uses data from a sample to draw conclusions about a population parameter or a population probability distribution. First, a tentative assumption is made about the parameter or distribution. This assumption is called the null hypothesis, and it is denoted by H sub 1. And an alternative hypothesis, which is denoted by H sub A, which is the opposite of what is stated in the null hypothesis. So basically, hypothesis testing is used to assess the plausibility of a hypothesis by using sample data. Statistical analysis tests a hypothesis by measuring and examining a random sample of the population being analyzed. Next, let's talk about null and alternative hypothesis. First, null hypothesis. A null hypothesis is a type of statistical hypothesis that proposes that no statistical significance exists in a set of given observation. The null hypothesis, also known as the conjecture, is used in quantitative analysis to test theories about markets, investing strategies, or economists to decide if an idea is true or false. Next is alternative hypothesis. It is a claim about the population that is contradictory to null hypothesis and what is concluded when we reject the null hypothesis. It is also defined that there is a statistically important relationship between two variables, whereas null hypothesis states there is no statistical relationship between the two variables. In statistics, we usually come across various kinds of hypotheses. A statistical hypothesis is supposed to be a working statement which is assumed to be logical with given data. It should be noticed that a hypothesis is neither considered true or false. So in other words, the alternative hypothesis proposes that there is a difference. Next slide. These are the tables that are commonly used in hypothesis testing. The z-test and t-test are calculations used to test a hypothesis, but they are most useful when we need to determine if there is a statistically significant difference between two independent samples group. Next is the steps of hypothesis testing. Step 1. Specify the null and alternative hypothesis. Step 2. Set the significance level. Step 3. Calculate the test statistics. And lastly, Step 4. Draw the conclusion. For better understanding about this topic, let's have an example. Jeffrey, as an 8-year-old, established a mid time of 16.43 seconds for swimming the 25-yard freestyle, with a standard deviation of 0.8 seconds. His dad, Frank, thought that Jeffrey could swim the 25-yard freestyle faster using goggles. Frank brought Jeffrey a new pair of expensive goggles and timed Jeffrey for 15 25-yards freestyle swims. For the 15 swims, Jeffrey's mean time was 16 seconds. Frank thought that the goggles helped Jeffrey to swim faster than the 16.43 seconds. Conduct a hypothesis test using a preset alpha is equal to 0.05. So for the solution, let's have the step 1, getting the null and alternative hypothesis. So for the null hypothesis, mu is greater or equal than 16.43, and for the alternative hypothesis, mu is less than 16.43. So step 2, setting the level of significance. It has already been determined by the problem 0.05 for a 95% significance level. To find the critical value, we need to select the appropriate test statistic. We have concluded that this is a t-test on the basis of the sample size, and we are interested in a population mean. We can now draw the graph of the t-distribution and mark the critical value for this problem. The degree of freedom are n-1 or 14. Looking up 14 degrees of freedom at the 0.05 column of the t-table, we find 1.761. This is the critical value, and we can put this on our graph. Step 3. It is the calculation of the test statistic using the formula we have selected. We find that the calculated test statistic is 2.08, meaning that the sample mean is 2.08 standard deviations away from the hypothesized mean of 16.43. So for the conclusion, with a 95% level of significance, we cannot accept the null hypothesis that the swimming time with goggles comes from a distribution with a population mean time of 16.43 minutes. Less formally, with 95% significance, we believe that the goggles improve swimming speed. So that's all for chapter 8. Thank you.